Alright, we are to the summary for Lesson 13. The topic for Lesson 13 is periodic properties. Periodic properties are characteristics of the elements which vary regularly and predictably across the periodic table. We're concerned with three of the periodic properties. The first one is atomic radius. Atomic radius refers to how large an atom actually is. So as we go down the rows of the periodic table, we're adding additional energy levels. And as we add energy levels, of course, the atom is getting larger. As we move across the periodic table from left to right, we're not adding energy levels, but we are adding electrons and protons. When we add the protons, without adding energy levels, they're able to pull harder on the electrons. So, as we move down the chart, we add energy levels, meaning the radius actually becomes larger because the electrons are going farther away from the nucleus. As we move left to right across the periodic table, the protons are pulling harder on the electrons, actually causing the radius to shrink because they can pull them in closer to the nucleus. So atomic radius increases going down, decreases going left to right. The second periodic property is called ionic radius, and it compares how large ions are compared to their neutral atoms. Remember, ions are atoms that now have a charge, either positive or negative. So here's an atom. See its nucleus, and then I'm showing its radius around the outside, and I'm identifying that as a neutral atom. If an atom loses electrons, it becomes a cation, meaning it has an overall positive charge. When we have an overall positive charge, the protons are able to pull harder on the electrons, and the radius of the ion is actually smaller than the neutral atom's radius. On the other hand, when atoms gain electrons, they develop a negative charge and are then known as anions. Well, the extra electrons then can't be pulled on as hard by the protons, so the radius of an anion ends up being larger than the radius of its neutral atom. The last periodic property that we're going to look at is called ionization energy. Ionization energy is the amount of energy required to remove an electron from an atom. So remember from when we worked on electron configuration, we learned that all of the atoms want to have 8 valence electrons to be like the noble gases over here. So ionization energy is referring to everyone except the noble gases because they're already happy. In general, the elements towards the left side of the screen will want to lose electrons because that'll make it easier for them to drop down to that next energy level, which already has a full number of valence electrons. The elements on the right side, in general, are going to want to gain electrons because that highest energy level is already almost full. They just need 1, 2, 3 more, and they will have 8. So because of that, so in general, the elements towards the left side of the periodic table are going to want to lose their electrons, and it's going to take less energy to pull them away because they already want to get rid of them. So the ionization energy is going to be less over there. The ionization energy is going to be greater over on the right side because, again, they're already almost at 8. They want to gain a couple of more. So the greater ionization energy over here, less over here. And then the other thing to consider is as you move down the periodic table, you're adding energy levels. As the electrons get farther away from the nucleus, it's harder for the protons to hang on to them. So the ionization energy is also less the farther down the periodic table you are, because those electrons are farther away from the nucleus and easier to get rid of. So in general, the ionization energy decreases as you move down the chart and increases as you move from left to right across the chart.